For the rational function, we'll find domain, intercepts, asymptotes, and whether or not the graph hits its horizontal asymptote, then use all that information to sketch the graph. Okay, so first and foremost, I always recommend that you factor. The numerator is a trinomial, so if it factors, it's a binomial times a binomial. This one does factor as 2x plus 1 times 2x minus 1, and you can refoil to check that out. The denominator is a difference of squares, which factors as x minus 2x plus 2. So they do both factor, but there is no canceling. Alright, so then now for the domain. Domain comes from where the denominator does not equal 0, and it's easier to use the factored form of the denominator. So this would become, when I set each factor not equal to 0, we have to throw out both 2 and negative 2 from the domain. Vertical asymptotes are very similar to the domain, particularly when we don't have any canceling, but this time we set the denominator equal to 0. And because the algebra is the same, we're going to get vertical asymptotes at 2 and x equal negative 2. Both x equal because they are vertical lines. They're not just numbers. Horizontal asymptotes come from looking at the degrees. So here, even though the factored form is needed to see if you're going to have a difference with your vertical and asymptotes and domain, but using the non-factored form is easier for the horizontal asymptote. We're going to compare the degrees of the numerator and denominator. The degree of this numerator is 2 because of the squared. The degree of the denominator is also 2 because the highest power of the denominator has a squared. So that tells me that the horizontal asymptote is y equal the ratio of the leading coefficients. So in the numerator, that's a 2 divided by, there's no number listed here, that's an understood 1. So we get a horizontal asymptote of y equals 2 because the ratio of the coefficients is 2 over 1, which is 2, and we look at that ratio whenever the degrees are equal to each other. Okay, so now for intercepts. Y-intercept. We plug in 0 for the x. So when we do that, the numerator simplifies to be negative 1, the denominator negative 4, and of course a negative over a negative is positive, so we get positive 1/4. The x-intercept. In general, the x-intercept comes from setting the entire function equal to 0. Here I'm going to use the factored form. The first step in solving this is to multiply by the denominator, which is x minus 2x plus 2, and that comes out to where the left side is still 0, the right side denominator factors, and we're setting the numerator equal to 0. And since I've used the factored form, then I just now set each factor equal to 0, which gives me answers of positive 1 and negative 1/2. So 2 x-intercepts. Okay, so the last thing I need to find is whether or not this hits the horizontal asymptote. Horizontal asymptote was at y equal 2. So I want to set the entire function equal to 2. Now on this one I used the factored form because I was setting it to 0, and I could see ahead that all I was going to do is end up with numerator equals 0, so I wanted it to be factored. But this time I'm setting it equal to 2. So if I multiply by the denominator, first of all, I'm not going to get 0 on this side, and I'm going to have to distribute. So because I look ahead and see that, I'm going to use the unfactored form. You would get the same answer if you use the factored form, but sometimes it's worth it to kind of think ahead to what's going to happen. Now I multiply by the denominator, which cancels on this side, leaves me with the numerator 2x squared minus x minus 1. Distribute on the left to get 2x squared minus 8. Now, when I combine things together, the x squareds will cancel out, I'm going to have a negative x on this side, so I'm going to move it to the other side to be positive x, and I'm going to add 8 to the other side. 8 minus 1 gives me 7. So this time I do hit the horizontal asymptote at x equals 7. Alright, now to tie that all together into our graph. We have vertical asymptotes at 2 and negative 2. We have a horizontal asymptote at y equal 2. We have a y-intercept at 1/4. I'm going to hold off on labeling that point for now. We have x-intercepts at both -1/2 and 1. And I'm going to hold off labeling those points as well until I get a better feel for where the graph is. Okay, so to get the graph, I'm going to put it on the calculator. Recommend that you put this in with the unfactored form. Okay, so I have parentheses. 2x squared minus x minus 1 divided by parentheses x squared minus 4. You have to tell the calculator. This is in the numerator by using parentheses. This is in the denominator by using parentheses. If you're going to use the factored form, you have to have parentheses around your entire numerator, which starts with another parentheses. So you would have to use like a double set of parentheses in both numerator and denominator. If you forget that, you will not get the right graph. Now, when I graph these on the standard window, they should be right on top of each other because they're the exact same function, and it looks like they are. The other way you can tell if you've put it into your calculator correctly is see if it matches the information you found. Use your reasoning. If it doesn't match, don't just trust what's here. Operator error. You probably put it in wrong. It should all coincide. Okay, so then now, from looking at this, my vertical asymptotes have divided my graph into 3 sections. The left, in between the two, and the right. The left one, I got to follow the vertical asymptote, and I'll also follow the horizontal asymptote. I know I can never, ever, ever hit a vertical asymptote. This time I do hit the horizontal asymptote, but only at x equals 7, and that's not on this part of the graph. So I will not hit the horizontal asymptote on this side either. I'm going to make it nice and curved and make sure it satisfies my vertical line test. Arrows at the end. In between the two vertical asymptotes, looks like I've got some kind of a little hump going on here. And I have these 3 points to hit. Okay, so again, follow the vertical asymptote but don't hit it. I go through these points, follow the other vertical asymptote, don't hit it. Arrows on each end. And now, before I forget, let me label these points. This one was at -1, 0. This one was at 0, 1/4. And this one was at -1/2, 0. Okay, last part. Again, I'm following the vertical asymptote and the horizontal asymptote. Never, ever, ever hit the vertical asymptote, but this time I do hit the horizontal asymptote at x equals 7. So here's x equal 2, 3, 4, 5, 6, 7. We'll say it's right there. So when x is 7, I have to hit the horizontal asymptote. Now that is difficult to see on this graph, and this is why I've picked this example to show you what can actually happen. So I follow this vertical asymptote, I have to come down and hit the graph here, and what happens is I pass through the horizontal asymptote and I go underneath it, but I never ever hit it again because this was my only place to hit the horizontal asymptote. So now it comes back up and I approach the horizontal asymptote from the bottom. So there's a little bit of a dip in here somewhere, and that's difficult to see on this calculator. Okay, but now we've used all of our information and we've tied it together to get a good graph of this function.